Okay, welcome to for our new topic, Module 12. So, this is relative motion of two particles using translating axes. So, last time atong gistoryahan ni ba is absolute dependent motion. Now, of two particles, karon relative motion of two particles. So, last time, absolute dependent siya because ang duha ka object or particle are connected nga kung mulihok ang isa, mulihok sad ang isa, di ba? Again, if we recall, for instance, we have this example. So, dependent ang duha ka system because if mulihok ni siya paingon diri, mulihok gyud siya diri, and kung mulihok siya paingon diri, si A pod musaka on that side. Okay? So, that is absolute. Here, we are talking about the motion of two particles nga dili dependent. No, they are not koan. They are not pre atong sa previous example or previous topic na ay links nilang duha. So now atong ginabuhat is ang ani nga part is na particles free from each other nga dili sila connected. But ilang motion is relative. So atong ginagamit diri is we use this translating axis. Unsa man yung axis, okay? So, ingon siya nga, throughout the course, the absolute motion of a particle has been determined using a single fixed reference frame. There are many cases, however, where the path of motion for a particle is complicated. Oh, yes, complicated siya. Diling siya yung single fixed reference frame. So that it may be easier to analyze the motion in parts by using two or more frames of reference. So, mo na dito nga, magamit ta og more frames of reference. So, di ba, usually itong ginabuhat kay natay usa ka frame lang or kanang pre ani isa ra gyud atong ginabuhat, di ba? Pag ang particle move. So from this reference frame lang gyud atong gina-observe. Pero karon naa natay gina-translate, di ba? Natay ang title is translating of axis. So natay first axis, then napod tay second axis. So if you notice sa ato ang symbolization diri, sa atong notation natay x, y, and z axis. And then, ani nga frame is na natin x prime, y prime, and z prime. So, ang prime here denotes nga naay movement. Okay, so for example, the motion of a particle located at the tip of an airplane propeller while the plane is in flight is more easily described if one describes first the motion of the airplane from a fixed reference and then superimposes the circular motion of the particle measured from a reference attached to the airplane. So, mana siya nga, if natay reference, mas dali na to ma-observe ang iyang motion. Okay. So, we talk here about position. So, if you, kung inyong tanawon dire, let's say this is the fixed observer. We have here the origin. And then this is the translating observer. So, kaning particle B is, it is moving, no? Pero dire siya nga moving, nani sila life. Kay mao man nila ang murag relationship nilang duha sa ilang direction. So, considers particle A. So, this is particle A and then particle B. Move along the arbitrary paths shown. So, the absolute position of each particle, A and B. So, ang R represents the position, A and B. So, di ba last time pag single fix lang itong kanon that we use S. Pag naanagani rectangular components, we use R. So, here we use R for position. It's measured from the common origin O of the fixed XYZ reference frame. So, mani ito ang reference frame. The origin of the second frame of reference XYZ is attached to and moves with particle A. So, muni ang particle A, and then from here, gamove siya. So, that's why we have new reference frame. So, the axes of this frame are only permitted to translate relative to the fixed frame. The position of B measured relative to A is denoted by the relative position vector RB of A. Using vector addition, the three vectors shown can be related by the equation. So, di ba, if we use a vector, di ba, itong pag-represent ni vector, it's either naka-bold ang letter. So, as shown here, naka-bold siya, R. So, this represents the vector position, the relative position vector. So, di mo na siya. So, di ba, ang other nga way na to pag show sa vector is natay katong arrow sa ibabaw. So, ang other niya nga way pag show is we have the bold letter. So, the relative position of B is just equal to the relative position of A plus the relative position vector kanina pong B of A. Okay. So, we have here the position. Again, so si position, di ba, o si velocity are related. So, same good yapon to siya. If we derive, no, if we differentiate again the position with respect to time. So, kapila na lagi balik-balik, no? If we derive position with respect to time, that is velocity. If you so manang we have the same relation here that V These are also vector quantity kay naka-bold ang V. So, yes. So, if we differentiate again the velocity with respect to time, so mahimo na po din na siya og acceleration. So, same na gyapon nga relation. Okay? So, we have a sample problem number 1 here. So, natay duha ka object. We have this, let's say this is a particle. This is the train. Train travels a constant speed of 60 miles per hour and crosses over a road as shown. So, naay train diri, and then naay automobile A. So, this one. If the automobile A is traveling at 45 miles per hour at this direction, si automobile, determine the magnitude and direction of the velocity of the train relative to the automobile. Okay. So, ang movement ni train. So, si train, iyang movement is horizontally paingon dire. Si train. So, it moves at, so ato ang movement ni or velocity ni train is 60 miles per hour. And then, kani si A, automobile A, paingon siya dira. Ato siya pangalan VA, no? It moves at 45 miles per hour. So, naay nakabutang diri nga, ang kani siya nga dalan is 45 degrees with this track sa train. So, that is 45 degrees. So, next, unsa may buhaton nato, di ba, these are vector addition. So, naamtay vector, naputay scalar. So, unsa may inaan nato? So, di ba, in this example, we have the, di ba, kung natay VV is equal to VA plus P of A. So, B of A is the relative position of B with A. So, here natay train, A, and then the automobile, pero wala tay V, T of A. Ang relative position ni train with the automobile. So, mo ni siyang meaning ani ha? Okay, so unsay buhaton nato if we write if we write this into like this, so we have that is the relative di ba kung natay position of B with respect to A, here we have the position of T with respect to A. Sa ato pa we wrote the equation as something like this. V sub T, velocity of the train, is equal to velocity of the automobile plus the velocity of the train with respect to A. So we have VT, that is 60 miles per hour. So ang direction ni VT is on that side. And then velocity of A, that is 45 miles per hour. Direction niya is 45 at 45 degrees from the horizontal plus the velocity T of A. So we don't know this one. So since naman tayo direction involved dire, this is a vector quantity. Kasi buhaton nato ani, we try to solve sa scalar analysis. So sa man ang scalar analysis, mura ra kang summation of forces ani, summation of forces x, summation of forces y. So same ra gyapon na ani. So if we resolve this vector into x and y component, no, di ba? Mura ra tang summation of force along x and y. So along x, let's say we have the along x, let's say positive ang paingon sa right as our general rule. So atong along x, that is 60 miles per hour. We have 60 miles per hour is equal to, so ang x ani, that is 45 miles per hour times cosine of 45 degrees plus ang x component ani ni v, velocity of the train with respect to A. So ato lang na siya i-denote as Vt of A x. Okay? Because this one has an x and y component, this one has an x and y component, but this one x component because it moves horizontally along the x component. So for our equation 1, we have this equation. So along y na punta, let's say ang pasaka is positive, so this is 0 diri nga side because velocity along train along y is just 0. Here we have 45 sine 45 degrees plus kaning velocity of the train with respect to the automobile y. Okay. So let's say this is our equation 2. So from these equations, makuha na nato si velocity of the train with respect to a along x ug along y. So ato la i-further simplify here, di ba? So we have the velocity of the train with respect to the automobile sa along the x component is just equal to 60 minus 45 cosine 45. So that is equal to 60 minus 45 cosine 45. That is equal to 28.180 miles per hour. And then for this second one, ato ang velocity of the train with respect to the automobile along y is just equal to this one. That is negative 45 sine 45. So that is equal to negative 45 sine 45. So negative 31.82 miles per hour. So atong x is along that side positive. Then ato ading kuan velocity of the train with respect to automobile is downward. Kay negative man siya. Kaya atong i-assume diri is positive man ang pasaka. Okay? So we have this values man paana siya og paana. Sa ato pa if we graph the movement of the particles of the train and the automobile. So natay ngani no. Ang automobile, ang train is horizontal lang, di ba? That is moving at 60 miles per hour. This is the velocity of the train. And then ang automobile is moving at 45 degrees from the horizontal. So this is the velocity of the automobile, 45 miles per hour. Sa ato pa ang direction ni, so we have here the velocity of the train with respect to A, mao ni siya ato ang movement. So this angle is unknown and we have these values. So di ba gipangutana ta what is the magnitude? And then so di ba we have the VT of A. So with respect to x is equal to pila ganito that was 28.18 miles per hour. So positive along x and then our velocity of the train with respect to A sa along y that is negative 31.82 miles per hour. So mo ni siya katong panaog. So we were asa magnitude and the direction. So from this graphical nga representation nato, we can get the value of this one gyapon. So by cosine law. So if our cosine law, we have the rule nga let's say c squared is equal to a squared plus b squared minus 2ab cosine angle sa C. Katong angle sa C. So, ang C squared na to ani, which is the unknown, this one. So, that is VT of A squared is equal to VA squared plus VT squared minus 2 VT times VA. Cosine then, ang angle nga opposite niya, which is 45. So, from this one, we have VT of A is equal to we have this square root of 45 squared plus 60 squared minus 2 times AB cosine 45. 42.504 miles per hour. So this is the magnitude of the velocity of our train with respect to A. And then for the angle, so if mao ni siya si VT of A, ato ading angle, we have x nga 28.18, that is VT of A along x. and then VT of A with along Y din nato is equal to negative 31.82. So ato ang angle diri nga theta. So theta is equal to pila? That is equal to, we have tan inverse opposite negative 31.82 divided by adjacent 28.18. So we have tan inverse opposite katong VT of A along Y over VT of A along X. So answer is negative 48.472 degrees. So negative siya because from this point panaog. So iyang relative direction from this side is equal to this one, 48.472 degrees. Okay, kung inyo na-extend diri, kung say angle diri, mausay angle diri. So this is our answer. This is the magnitude and then this is the direction. So sa magnitude, actually, pwede na gyapon nato, wala na nato nagi-cosine law. Pwede na nato to siya gidiretso. We have 28.18 squared plus 31 plus negative 31.82 squared. Then we will have the same answer, 42.504 miles per hour.